Okay, hi everybody. So we have here a mass spectrometer, which is used usually to find or calculate the masses of very small ionized particles, such as alpha particles or any ionized metals or elements such as copper plus 1, Fe plus 2, and Fe plus 3, and many other ions. In this example here, so we have two ions, Fe plus 2 and Fe plus 3, fed into the mass spectrometer and accelerated through a potential difference that is given to be 350 volts. As they enter into a magnetic field that is coming out of the paper of a value 1.13, the paths of these two ions are bent into a circular trajectory, and both of them will have different paths because the charge on each ion is different. Since this one is bent more, I think, and you will see later, that this should be Fe plus 3 path, and this should be the Fe plus 2 one. This happens basically because the magnetic field acts with a bigger force on bigger charges, and this is Fe plus 3, so this is a bigger charge than this one. Okay, so the equation for a mass spectroscopy is basically this one. Mass is equal to the absolute value of the charge times r square times the magnetic field square divided by twice the voltage difference. R here is the radius of the circular trajectory. We need to find in this problem the distance between the two ions when they fall on the screen. So one ion, which is Fe plus 2, comes here, ends up here, and one ion, Fe plus 3, ends up here. Now we need to find this distance in between. The strategy to do this problem is to find radius for Fe plus 3 and radius for Fe plus 2. Then we can do some calculations to find this distance. Okay, so basically this equation, which is the mass, have to be written in terms of the radius. So if we do that, the radius can be written like this, in terms of the same equation after some algebra, and it will be equal to 2 times the mass times the voltage difference divided by the charge Q times the magnetic field square. Okay, now let's find R1 for Fe plus 3. Okay, so let's write here R1 is equal to, I'm going to make a big square root here because we will have a lot of numbers, and 2 comes down. The mass of the ion is 9.1 times 10 to minus 26, and it should be the same mass for ion Fe plus 2 or Fe plus 3. Now the voltage difference is given as to be 350 volts. So the mass is in kilogram and the voltage difference is in volts. Now divided by the charge, which is, okay, the charge of the ion. The ion has a charge of plus 3. What does that mean? It means that it lost 3 electrons. So the charge in meter kilogram system should be what? 3 times the charge of the electron, which is 1.6 times 10 to minus 19. This should be given to you, the charge of the electron. Now B is the magnetic field, which is 1.13, but it's B squared, so we have to square it. Now do this calculation and we will find that this radius is equal to 0.0101385, and that's in meters. All right, now let's find R2, and the same thing applying this equation. So if we do that, I'm going to say R2 is equal to We're going to solve it. 2 comes down. The mass is the same, 9.1 times 10 to minus 26, and the voltage difference is also the same, 350 volts, and this should be divided by, now the charge of Fe2 is what? 2, which means that it lost 2 electrons. So divide by 2 times the charge of the electron times 1.6 times 10 to minus 19, and that's also multiplied by the magnetic field square. If you do this calculation, you're going to find R2 to be equal to 0.012417 meters. As you notice that R2 is bigger than R1. R2 is bigger than R1, and here it is the same. Now, how do we find this distance? Look, R2 is the radius for the big circle. R1 is the radius for the small circle. If you multiply R2 by 2, you get this whole distance. This distance actually is 2 R2. If you multiply R1 by 2, it's this whole distance. This is actually 2 R1. Now to find D is basically D is equal to 2 R2 minus 2 R1. So I'm going to take this here and do it here. So D is equal to twice R2 minus twice R1, or the diameter for the big circle minus the diameter for the small circle. And if you plug in the numbers correctly, is equal to 0.004547 meters. That's it. Thank you very much. I hope this helped.